first of all, we'll be discussing what is disaster management. Since we have just begun with this introductory session initially since the last 2 days, so I'll be taking up the basics of disaster management initially, and then coming on to what is remote sensing, and then we'll come on to how remote sensing is used these days in different forms in managing disasters with examples and case studies. So first of all, I'll begin with the concept of disaster. And since the last 2 days, you must have got a basic idea of what actually is a disaster. But there are certain dimensions which we can observe in the case of disaster as an event. So if we take in terms of its definition, a disaster can be any natural or human generated event. So these underlined words are the key words. So we basically have natural, then we have human generated, calamitous event which can produce great loss of life or destruction of environment, property, infrastructure. So there are certain components which actually make up the definition of what a disaster is. So A, it can be natural, it can be human generated, and the main thing is that it has a calamitous nature. And even if it has this, the main identifying factor is that there is a great loss, and that loss can be in terms of life, property, environment, infrastructure, or a total of all of these. And the etymology of the term disaster is coming from the French word, which is désastre, and it is a combination of two words, da or des meaning bad and aster meaning star. So the term disaster actually refers to something which is bad or something which is evil. And if we take in terms of definitional aspects, the World Health Organization defines a disaster as a sudden ecological phenomena of sufficient magnitude to require external assistance. Now, this definition is important because if we take disaster in terms of any specific event, any event which takes place on and off, it is not that. So, first of all, it can be sudden because if we know that something is about to happen, we can control it. But since it is sudden, that is why it is a disaster. It is an ecological phenomena. So we are not saying it is environmental, ecological, because ecological is a combination of the natural and the human induced phenomena. So it is ecological. And the third direction which this event takes is that its magnitude or its strength is that much that it requires some external assistance. That is, people or population who are affected by this particular event, they are not able to actually, what we can say, maintain it or sustain themselves at that point of time when this event has taken place or when it is taking place. So that is why the dimension of a disaster is totally different from any other event or any, what you can say, a call of a regular event. So this is something which is specific. Now, when we take in terms of definitions, why different types of practices are coming in disaster management, why we are discussing remote sensing. So before knowing what actually we are doing, we should know for what we are doing. So after this definitional aspect, we see how disasters take place and what are the types of disasters. Now, I'm taking only the basics here, otherwise the details of disaster types and uh, definitional aspects, all these we will cover in other lectures. So the basic introductory aspect which I'm touching here to make the format for the further presentation. So if we take the basic categorization, we observe that disasters can be of two broad categories on the basis of the cause or the causes. The first cause is natural, in which come the earthquakes, floods, droughts, landslides, cyclones, volcanoes, wildfires, storms, tsunamis, and so many of them, which are interlinked with these basic events. And when we take the main causation factor of human induced disasters, then some natural disasters also come into this category. But basically, these are the ones which are caused by human activities. For example, forest fires. Now, fires are taking place in a forest, which is a natural environment. But when humans are causing it, it comes under the category of human induced disasters. Then we can have examples of violence, accidents. A very specific term for human induced disasters in terms of classification comes as CBRN, which is a combination of chemical, biological, radiological, nuclear, and or any of these categories. So we have CBRN category of disasters, crime, cyber attacks, terrorism, deforestation, etc. So if you see, the categorization is very clear. The main factor which we are analyzing is giving us the category of disaster. And one additional thing which you might not have come across, maybe, so disasters, they are also capable of further causing disasters and emergencies, both. And it is a kind of what we say a domino effect. So if a disaster is taking place, then it can also lead to a further disaster. And this situation on the whole can create emergencies, which are also a kind of an outcome of these disastrous events. So, natural disasters and emergencies can include floods, hurricanes, earthquakes, volcanic eruptions. And why they are emergencies? Because they have immediate impacts on human health, infrastructure, secondary impacts causing further death, suffering from events, and they also cause further events such as landslides, earthquakes, fires, tsunamis, or other widespread associated events like flooding. Flooding causes storms. Storms can cause the sinking of boats, floods, which cause landslides, etc. So, disasters, they have a domino impact on creating further disasters and also emergency like situations which need management. So, both emergencies and disasters, they require management. So we can have natural disasters and emergencies. We can have human-induced disasters and emergencies, again arising out of those categories. These emergencies can be CBRN, which we have just discussed, technological, industrial accidents, basically involving hazardous material, and occur where these materials are produced, used, or transported. Large forest fires are included in this definition because they tend to be caused by humans but generate multiple impacts. So, any impact can generate further impacts. Any activity or event can lead to a further event, which again can turn into a disaster. This is a very specific, not too much discussed point with respect to disasters. And these emergencies can further become complex. They can involve a breakdown of authority, looting, attacking on strategic installations, because if there is a shortage of, say, any food product, or if there is violence, if there are riots, then the strategic installations or infrastructure is always under danger. Complex emergencies include conflict situations and wars. Like currently, some countries are experiencing these kind of emergencies. The reason can be anything: political, economic, social, or a combination of all of them. But they are situations which demand an external assistance. Then we can take pandemic emergencies, which all of us have experienced very recently. These emergencies, they involve a sudden onset of a contagious disease which affects health, but it can also disrupt the services, businesses, and all other social fabrics, economic fabric, and basically they bring economic and social costs. And COVID 19 is the recent most example. I mean, it does not need any specific introduction. So we can have a disaster, causing a disaster, followed by the emergencies, which can be of these basic categories. Now, I have a question. I mean, why disasters they take place? So, there's a link which I can share with you in the chat box. So, please click on this link. It's a one-line survey, and you can respond to it. I'll get the responses. And please provide the response in one line. You can copy this link in the browser and directly go to the survey. So I have posted it. So the question which we are dealing here is that why are disasters taking place? Please take 2 3 minutes, decide upon it, and just give me a one-line response, whatever you feel is the most near to it, or which is most appropriate according to your perception of a disaster. Why disasters take place? Please let me know if you are able to access the link. Yeah, please reply. Thank you. The question is why disasters are disasters. So I've got two answers as of now. Yeah, there's a hand. You have a question?
No, ma'am, no question. The disaster means any sudden or onset calamities or some situation that cannot be handled by the community people at their own. Then
Right.
they need external help.
Yeah, can you please put it in the answers? So it is 5:16. I'll open the survey for another, say, 30 seconds or 45 seconds. Till 5:17, I'll be taking up this survey. So why do you think disasters are disasters? Just a one-liner.
रिस्पॉन्स करूं प्लीज.
So this will be very interesting because when you will, I suppose you will find the answer, you will say, okay, most probably no one will be having that answer. Or might be someone if you hit the target. Okay, so it's 5:17. I'm closing the survey. So basically, the
And
question we are
what
dealing here is that why. Can you please lower your hand? And you have to mute yourself. Mr. Ghosh. Yeah. So we are here discussing why disasters take place, and I have received only two responses. But I mean, all of you are focusing on the right aspect, which is technically or definitionally absolutely right. That these are calamitous, these are natural events, human-induced events. They are out of control. But there is one another dimension of a disaster, which actually is the whole philosophy behind disasters. Why are disasters taking place? They are taking place because population, property, resources, they are negatively impacted and disrupted. If an earthquake is taking place, say under sea, or if it is taking place in a remote area, it cannot be termed as a disaster. So, if you put it in terms of its basic nature, a disaster is only happening When people are impacted, when population is impacted, when resources are impacted, when we have the property which is getting damaged. Otherwise, no event is a disaster. So when we have the negative consequences which cause loss, and obviously they are out of control in terms of the existing infrastructure, then only a disaster is taking place. Otherwise, no event is a disaster and nothing requires management. So disasters are taking place or disasters are there because people, population, and the infrastructure is impacted. So if we have this notion, if we have this idea of the discipline, then we can actually have the perspective of what we are managing. I could have straight away started with, okay, remote sensing, this is remote sensing, this is disaster, this is management. But no, we should, at least in the initial stages, like you are in this FDP, have should have all perspectives of what the issue actually is. So in terms of defining what is a disaster, it is actually an event. Certainly, it is an event. All of us have given this definition, capable of causing harm. That is the main aspect. It is only a disaster. A disaster is only a disaster when it has the capacity to harm or impact. Otherwise, we cannot say that event has any significance to us in the aspect of disaster management, because if a disaster is taking place, only then we can manage it. So a disaster is only a disaster when it has the capacity to harm humans and associated property and life of any form. And then what we have discussed right now is disasters can also lead to other disasters. So with this aspect of defining disasters, their basic nature, we'll now proceed on to what we are managing. What is disaster management? So I have a very short survey. This will be the last survey. Does every event lead to disasters? So I'll post up this link, and you can reply to it in yes or no. Or if anyone wants to reply verbally who is not able to access it, please let me know. So it is 5:21 till say 5:22. So I've got four responses. Four responses, and three of you say no, every event is not causing a disaster. Anyone else who want to reply? Okay. So basically, the majority is right. Every event is not leading to disaster, certainly. And why this is happening? Because it can be that the event can be diverted, it can be changed, or it can uh, be averted due to specific management practices. Now, after having this discussion of what is disaster or what are disasters, what are the definitional aspects, we see how do disasters actually take place? Now, always we think, okay, a flood has taken place, earthquake has taken place, it has turned into a disaster. But is it that simple? Now, if the river is flowing, if the water is suddenly coming, it is impacting people, but why it actually now converts into a disaster? So, when we discuss these aspects, the main consideration, which is very specific to the disaster management or disaster studies literature, we have certain conceptual issues in this. So, these definitions are, or these terminologies are hazard or hazards, risk, and vulnerability. So, unless there is a hazard followed by a risk or preceded by a risk and there is vulnerability, then only a disaster or that event has the capacity to impact. So, the disasters are taking place from hazards to risk to vulnerability to disasters. So that is why I've taken this heading here. It is actually from these. So any order can take place here, from risk to hazard to vulnerability, from hazard to risk to vulnerability, or any other order. But basically, all these three are involved. Without any one of them, the disaster situation cannot take place. Now, in that sense, we see what actually a hazard is. This is not in a specific order. The order can vary according to the situation. So, what is a hazard? It is a dangerous, risky circumstance or circumstances which have sufficient potential to cause a threat to human life. And in case you remember or recall the definition of disaster right now, you will see that the capacity of a disaster is not a threat, it actually causes the harm. So it is a stage which is prior to a disaster, that there is actually some danger, there is some risky circumstance which in the future has the potential. So that is why every event cannot lead to a disaster. When we come on to the definition of risk, we observe that it is the potential loss of life, injury, destroyed, damaged assets, or and any of these which could occur to a system, society, community in a specific time period. It is determined probabilistically and it is a function of hazard, exposure, vulnerability, and capacity. Any literature you read on disaster management will give you these three words which are moving with each other. So the UNDRR, which is the apex agency of dealing with disasters, it is defining it as a potential. Again, if you correlate it with the definition of disaster, you will find disaster is not a potential loss, it is actually the loss of life, property, and assets occurring to a system, society, or a community in a specific period of time. But disaster is not determined probabilistically. Risk is a probability that this is the possibility of something happening. A disaster is not a possibility, it actually has taken place, or it is taken place, or it is after the disaster that things are discussed. But it is a probabilistic function of hazard, exposure, vulnerability, and capacity when we see the factor of risk. Vulnerability is a very important aspect, the third part of the triangle. Vulnerability describes the characteristics and circumstances of a community, system, or asset which make it susceptible to the damaging effects of a hazard. So, how vulnerable a population is determines what will be the impact or what will be the outcome of any hazardous event which turns into a disaster. And there are many aspects of vulnerability which arise from physical, social, economic, and environmental factors. And we can have full lectures on vulnerability as a component of disaster management. We can have full lectures on hazards, full discussion on risk. So these are that detailed in terms of their analysis. But when we take them simplistically, we observe that vulnerability can be of different kinds. A person can be physically vulnerable due to any incapacity. Maybe the person is sick or some sort of disadvantage is there. Economically, weaker sections are always more vulnerable. Environmental, maybe the ecosystem is situated at a particular place where the vulnerability is more, or there can be social vulnerability where societal factors make the system more vulnerable, like we are seeing in some countries these days, the conflicts which are going on. So that makes the population vulnerable, and there can be a combination of any of these or all of these. So after this, we come on to how we actually visualize this whole situation in disaster management. It is called as the disaster risk equation, in which we observe all the components in a specific relationship. Vulnerability multiplied by exposure or the risk multiplied by the hazard, it can be natural, turns into a disaster. So this multiplication has an importance. We are not saying addition, we are not saying division. We are basically multiplying because all these have an exponential impact on the other. So the disaster risk equation is suggesting that risk is equal to hazard into vulnerability as a multiplying impact divided by the capacity to cope. So if the denominator is strong, then the output is less. And it is a very simple mathematical equation which all of us are familiar with how to interpret it. And if you put any of these parameters on the other side, obviously you can derive the other parameter. So if we take it with the perspective of risk, then the equation is like this. You can put hazard at the place of risk, you can put vulnerability at the place of risk, and if you put the capacity to cope in place of risk, then the equation gets altered in terms of interpretation. But it is that simple to understand that the impacts of a disaster are an outcome of vulnerable situations and the exposure, but it is a multiplying impact. We cannot say it is 1 plus 1, it is 1, 2 to the power 2, or 2 into 2 actually. So the risk of a disaster increases as the frequency or severity of hazards increases, people's vulnerability increases, and people's capacity to cope is decreased. So the stronger the denominator, lesser is the impact or the risk factor of any disaster which is involved. And it is a very, you can say, a popular equation in studying disaster management. Now, after this, we come on to the last part of the basics of disasters in terms of understanding as per this topic. It is, what is disaster management? What are we discussing in disaster management now? We have an idea of what are disasters, why, how they are taking place, what are their kinds, what is the philosophy behind studying disasters. Then we see that how disaster management can take place. Now, it is very interesting to interpret this diagram. If you want to put any interpretations, you can put in the chat box. Looking at this diagram, what are your observations? It is called the disaster management cycle. You can take a minute, it is 5:31 till 5:32. Anything which comes on to your mind when you see this cycle, why we are discussing disaster management, we have done. Now, what is disaster management? How do you observe this whole fabric of things? Anyone can comment. Okay, so it is a cycle. Very interestingly, why it is a cycle? Because if you observe it, it is not having any starting point and it is not having any ending point. And very interestingly, you can pick up from any of these tabs and start the management process in terms of its basics. We can either begin from recovery, we can begin from preparedness, we can begin from disaster, which is not too good actually, or we can have a response. Now, if you see, but even if it is not having any starting or it is not having any end, it is actually showing you a particular process, and there is a logic to this process, there is a logic to this interpretation of what is disaster management. So if we start, say, with let us start with preparedness. We are prepared for something. Why we are prepared? Because we know that there is a potential of harm in that particular event, or it has a possibility of causing harm Risk is involved, vulnerability is there, people or population and resources, they are exposed. So we prepare beforehand in different manners depending on the kind of disaster. That is another school of study for every specific disaster. After preparing it, we move on to mitigation. Now we have a plan. Now we will do the practical steps how we can mitigate these impacts, the negative impacts. Sadly, if the disaster takes place, then we have to respond to it, and then we go on to the recovery process, and then we prepare that okay, in the future maybe we can negate such things, or we can come across any other later factor, so we have to again manage it. So if you see, even if it is a circular or it is a cyclical process where you don't know where to start, there is a very strong logic behind following disaster management. So you can begin from any of these. If you start from the recovery process, you have to prepare, you have to mitigate. And there might be a possibility that later on the disaster does not take place, depending on the outcome of that mitigation. Or maybe if they are really successful, the disaster might not take place, the cycle can break off, and we can say that the area is so-called safe from that disaster. But obviously, it cannot be 100% because natural disasters and other human-induced factors, they are totally not 100%, you can say, avoidable. But still, there is a logic which is operating behind this cyclical process. And this is giving you more detail. Crisis leads to response. Our target is to save lives and minimize immediate impacts. Then we can go on to recovery to restore the activity and services. We can go on to prevention to minimize impacts of future disasters. And then we can again prepare the same thing in a more detailed form. And the central part is showing you a portion which is given to disaster, after disaster, and pre-disaster. But we cannot alter these stages because they are following a specific logic. So finally, when we sum up, we see that disaster management is a process of effectively preparing to respond to disasters. We are not here saying that we will control the disaster, we will stop the disaster, or we will, okay, don't let the disaster come. That is our implicit aim. But in case any of such thing happens, then our preparation should be such that we are able to respond. And many developed nations of the world, they are effectively prepared against many of these things. It contains strategically organizing resources to reduce the harm caused by disaster. So we have to be prepared that in a situation where we are not able to control that event, or if it is a regular event like floods we have in the Northeast, but we still have to organize our resources in a manner that the harm is minimized, although we cannot control the harm 100%. Further, it also involves a systematic approach to manage the responsibilities of disaster prevention, preparedness, response, and recovery. So we cannot say, okay, we are preparing because disaster will come. Disaster will come in 1 month. When rainfall is taking place, definitely flooding will take place. We are not going with that aim. We are going with the aim that we have to prevent it. If a situation like flooding can be avoided by any construction or any other, say, measure, then we'll try our best to pursue that rather than waiting, okay, the flood will come and then we'll give on relief and rescue. It is not our target. So responsibility of prevention is the first thing. We can prepare ourselves, and then in case it happens, then we have to respond and then go on to the recovery process. And disasters are summarized very effectively. This is called the pressure model. It shows the conditions or the methods through which actually disaster can take place. So on one hand, you see on the right hand side, we have the hazard. It can be of any form, natural or human induced, storm surge, flooding, sea level, etc. On the left hand side, there are root causes of everything. Everything has a basic cause. Now again, I'll pick up that first point, that unless it is impacting, it is not a disaster. So there are certain pressures which convert it into unsafe conditions. Root causes can be power, structure, resources, political system, economic system, or any restrictive thinking. These are the main underlying causes of any such issue. Then if pressures are operating on it, say for example, population increase, increased urbanization, increased traffic, debt, deforestation, decline in productivity, ethical issues, or social issues, then these pressures, they actually, what you can say, mold the condition into unsafe ones, and these are turned into unsafe conditions from the causes through the pressures, and they cause a disaster. And the disaster, if you see that star diagram, it is showing you risk is again hazard into vulnerability. So on the left hand side, you have the factors causing vulnerability, and the right hand side is giving you the hazard. And at the top, you can see the progression of vulnerability. Vulnerability is progressing, it is increasing in strength. The arrow is showing you the strength of vulnerability, that from the causes, the pressures, they increase vulnerability, and ultimately the unsafe conditions, they lead vulnerability to a condition where it can convert into disaster. And unsafe conditions can be physical conditions, socioeconomic, institutional, lack of public preparedness, endemics, diseases, low income, so many of them. So, this is called the pressure model in disaster management studies. And finally, disaster management is before the disaster, preparing for it and reducing the risk. If the disaster is taking place, we have to respond. And if we begin with preparation and the disaster still takes place, we have to recover from it. And if we reduce the risk and still the disaster takes place, we have to reduce the risk of disasters. So the steps which are involved in disaster management, which we have seen basically, we have the one line explanation to it. First is prevention. Prevention is the best way to address a disaster by being proactive. This means identifying potential hazards and devising safeguards to mitigate their impacts. Now, mitigate their impacts gives us to mitigation. Mitigation aims to minimize the loss of human life and property which would result from a disaster. And in mitigation, we can have structural and non-structural measures, simply meaning that if, for example, a flood is there, some structures like embankments or dams can be constructed. Non-structural basically involves the policy measures. Then we have to prepare. Beforehand preparation, basically, it is an ongoing process in which individuals, communities, businesses, and organizations can plan and train for what they will do in the event of a disaster. So it is not only one person, it is not only one, say, organization which is given the responsibility. It is actually a combination. And at the time of disaster, no one knows who will be required at that point of time. Response. Response is what happens after the disaster has taken place, and it involves both short and long term responses. And finally, when the disaster has taken place, like we have seen in the earlier diagrams, there is a recovery. The fifth stage in the disaster management cycle is recovery. It takes a long time, basically, and sometimes years or decades. It involves stabilizing the area and restoring all essential community functions. Recovery requires prioritization. This is I'll not say a sad part of recovery, but it is actually the requirement, because one has to prioritize. The government or the institutions, they have to prioritize what to recover first: income, society, people. First thing is the basic requirement. After that, what to recover. So it requires prioritization. So we'll take a break for 2 minutes. If you have any comments or questions or any observations, please feel free to discuss. It's 5:42 till 5:44 we can take, or we can take a break for 1 minute and then proceed on to the next part.
Yes, ma'am. Yes, sure.
So it's 5:42. I can begin at 5:44.
Yes, ma'am. No problem. No issue.
Any questions, anyone?
কার প্রশ্ন আছে কিছু? প্রশ্ন
Yeah,
থাকলে
please.
জিজ্ঞেস করো। Yes.
Okay, so let us continue. I hope you are okay with the speed.
Yes, ma'am. Please.
Okay, so now we come on to the second part. After seeing what disasters are and what we are managing, let us see what is remote sensing actually. So, remote sensing is also defined as a secret weapon of disaster response. Basically, it is a combination of techniques involving remote sensing and GIS. But my focus here is remote sensing because GIS in itself is a separate topic. So it is called the secret weapon. Why it is so discussed or why it is so required and becoming so popular? It already is actually. So that we'll see in the upcoming slides. So defining remote sensing. Now there are two words in it. If we keep into consideration these words only, we'll be able to identify what follows up. It is remote and it is sensing. So we are sensing something, but we are not actually in direct contact with that particular object, and we are at a very specific distance from it. Now that distance can be anything. How this philosophy translates into remote sensing, that we'll see in the upcoming slides. So remote sensing refers to the use of satellite and aerial images to gather information about the Earth's surface and environment. In case you're not able to get what satellite and aerial images, some of you might be aware of these. We'll see later on what actually we are dealing with here. Remote sensing as a process is detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance from satellite. Special cameras on satellites collect remotely sensed images which help researchers sense things about the Earth. So basically, it is very clearly saying that we are detecting something, we are monitoring something that is a geographical feature or any object on the Earth's surface, and how we are doing it. That is the main thing. So, the philosophy behind remote sensing is that every object on the earth emits a specific radiation in a specific wavelength. These are the concepts of physics. So anything right now, say if you are in contact with anything, any object, table, pen, curtains, buildings, trees, mountains, any minor to major thing on the Earth's surface is reflecting radiation. Now that radiation can be in different forms. Basically, it is an outcome of the temperature. So any object which is absorbing sun's rays is emitting some radiation, or any object which is absorbing heat is giving some radiation. So all that radiation has a specific, what if I take it in simple forms, numerical value which can be measured through instruments. And these instruments, when they are put on a specific platform, they give us an output in a one liner. This is remote sensing. Later we'll come on to the technical aspects of this also. So if you see this diagram, you have the earth, objects are emitting radiation, and there is a sensor which is collecting this radiation, and there's a station which is receiving them back, because unless that radiation is received and given back, we cannot measure it. If we put a station, if you just ignore this part and if you only see the right hand side part, it has no meaning. If you ignore this right hand side part and you see only the left hand side part, this definition or this concept has no meaning, because unless you have a receptor or you have a sensor, the process is incomplete. It cannot take place. So starting point is an object, it is giving radiation. This radiation is measured by this satellite, and this satellite interestingly gives it back to the station in terms of what form, that we'll see later. And that recorded information is the information that is derived from remote sensing techniques. So if you simplify it, it is in this form. There's a satellite, you have the sun as the main source of energy. It is giving its rays on every object. Every object is giving radiation back according to its own nature. This is recorded by the satellite, which is giving it back to the station. So it is giving you the first stage of remote sensing, incoming radiation and outgoing radiation. And the next part will be that this radiation is given back to the station which is recording it. And what is the nature of this radiation? It is called the electromagnetic radiation. This is the wavelength, and this is the visible light. For example, any vegetation which is healthy in nature will give radiation back in this color. Any vegetation which is unhealthy in nature will give radiation back in these red colors. So from the satellite imageries, when you get this red color information for an area, you definitely know that it is not a healthy vegetation. So that is how the logic is operating. And there's a visible light, and there are certain areas which are called atmospheric windows in which remote sensing operates. These are the various kinds of electromagnetic magnetic radiation categories. So we are not here dealing with the physics of it, but we are going with the overview of the process. And wavelength tends to decrease with the specific categories of this EMR or electromagnetic radiation. So we have the visible light, which is into these categories. Visible light has these frameworks. After that, these are not visible on the right hand side and on the left hand side through human eyes: infrared, microwaves and radio waves, ultraviolet, X-rays and gamma rays. How is remote sensing working? Remote sensing information can be used to create high resolution maps and images of the impacted area. So I am simultaneously now putting disaster management into this. It provides crucial information on the extent and severity of the damage. Now, when we have information, our concern here is disaster. So I'm not diverting from the topic. So basically, we see which area is impacted, how it is impacted, what is the extent of damage, how severe it is. And in disaster management, remote sensing can be used to monitor changes before, during, and after a disastrous event, to assess the damage and the loss which is caused by the disaster, to support emergency response and relief efforts. And one of the best examples are the mountainous areas which are inaccessible. So for this, again, the basics are discussed. Some sort of energy is required. It can be from the sun for the satellite, or it can be a method which is there within the satellite. This satellite or sensor, it's not always satellite. Remote sensing is more popular through the satellite these days. It can be any platform, but remote sensing through satellites these days is giving us the best information. So a certain platform is required which records this electromagnetic radiation, and a computer system which is processing it for analysis. This is how interestingly we can observe it. Sun's rays coming on every object on the earth, it is giving back. If you see, say, a road, a mountain, a tree, or a field, all of these are giving energy back, which is received from the sun. It is recorded by the satellite, and then it comes back again to the earth, but it is not coming back again to the earth for our analysis. It is coming back to the station, which is receiving it. This station can be the satellite data receiver, or it can be the GPS, global positioning system, like our phones. All of them are having GPS, which is inbuilt. So we have the source of illumination, basically the sun or any other thing which is giving light. Source of energy: interaction with the atmosphere, interaction with the target. Target is any object, tree, vegetation, etc. Interaction of energy with the atmosphere. Now, this energy, very importantly, is passing through the atmosphere, and atmosphere has so many components: dust particles, pollutants, moisture, different properties of air at different places, thickness of atmosphere. Then you have pressure conditions, temperature conditions, climatological phenomena. All of these are having a lot of impact on the energy which is giving back, and energy which is given back by the object. And this energy is recorded by the sensor. This sensor transmits it and processes it and gives it back. And finally, we interpret this, which is our process of interpretation in remote sensing and GIS. Remote sensing platforms, how remote sensing operates. It takes place on a platform, which is a stage where actually we have to put that instrument. It is that simple. We have to sit on a chair. It's a similar thing that the satellite has to be put on a platform, which can be of different nature. So platform is a stage where sensor or camera is mounted to acquire information about a target under study. For remote sensing application, sensors should be mounted on a suitable base. These can be ground-based, airborne, or space-based. As the platform height increases, the clarity will increase because disturbances are not there, and the observational area also increases. Thus, higher the sensor is mounted, larger the spatial resolution and view. Types of platforms can be ground based, air based, and space based. Ground based are basically at a certain height. Airborne are aircrafts which are there in the air, they are taking photographs. But spaceborne platforms or satellites are the ones which are more discussed these days, and they are giving us more detailed information. We should just know how to interpret them. So the main categories of remote sensing platforms are spaceborne, satellites or shuttles, airborne, aeroplanes, helicopters, hot air balloons, airship, other kinds of balloons. Ground based are handheld or raised platforms. But basically, when we talk of remote sensing, we are largely discussing the spaceborne category. This is just an example. There are multiple satellites and they are orbiting the Earth like anything these days. And this is how the satellite operates. It is situated in a certain path. If it is oriented towards the Earth, I'm not going into the details, these are not required here. So you have a geostationary orbit. If it is oriented with respect to the Sun, it has a Sun synchronous orbit. If it is oriented towards the Earth's poles, then it is a polar orbit, and there can be so many other dimensions. So these are some examples. We see INSAT, India satellite. We see MTSat, Japan, Meteor 3M, Russia. These are just some basic examples. There are so many of them. But in space, please visualize how remote sensing is operating. And this is the process, the energy which is given by the objects on the Earth, they are taken back by these sensors. So this satellite or sensor is giving radiation, it is giving signals, and the object is giving radiation which is recorded by this particular satellite. And there can be so many satellites which are moving in a specific path. Now, these are some examples you see. Now, if you see this, you will find that there are different natures of these imageries or images which are taken from satellite. This is actually showing you the area, but this one is giving you an idea of what this can be. This is also giving you an idea. And here also you can see that, okay, this is a river valley, and then we have the mountains on the sides. And again, there's a river flowing. So these are not actually drawn through any, what you can say, color system. It is actually what has been derived from the satellite. And it depends on the nature of the satellites, its specific properties, its specific calculations, and what output it is giving. So for some things, you can clearly identify, okay, this is a hill and say these are settlements. But for images like this, say for example, if it is not clear, then we see it with the base map of that particular area to see that, okay, this feature is a settlement, or this feature is a field, or if this feature is a tree cover, whatever the region is having. But these days, the imageries have advanced so much that we can identify the features very clearly on the basis of the specific observations of the bands of remote sensing. That's a totally different technique, but I'm introducing the basics here so you can visualize how the process of remote sensing operates. So these are all remotely sensed images, but the nature of each of them is different. This is for Ankleshwar. This is natural color composite. This is called a false color composite. This is the digital elevation model for a particular area. So this is how we derive the information. It's a combination of things here. This is for a cyclone, and these colors, they have a meaning. These are showing you the wind speed or temperature. Then you can observe the sea surface temperature in a specific area. These ranges show the differences. And obviously a sea is blue in color, so if you measure the temperature at different places going in ships, it is very difficult. But through remote sensing, you can find that, okay, the satellite imagery is giving us this area under these categories, so automatically we can map out the areas with high temperature or areas with so many other issues which are under discussion. This is also false color composite of a river. And beyond the river, I mean, these red and blue colors, they are showing you something, but you cannot examine what it is unless the information is available for that particular area. So this blue color is giving settlements, this red color is giving agricultural fields and vegetation. But we have to, at certain places, through the remote sensing images, find out what that area is providing us, because the remote sensing cannot exactly at times record due to the limitation of its sensors. But these days, the advancement of technology has taken place, so we are able to analyze. But in many cases, and earlier, these kind of images were drawn, which were slightly difficult to interpret unless you had the ground information. But it is again very useful because uh, otherwise, this information cannot be taken. This is a settlement area. So if you see the growth of this settlement over certain years, this information is not available in the maps. We have to take it through a data source which is giving you a combined analysis, and a geographical analysis in such a case is the best exemplifier. And that information only comes through remote sensing. That is why we are saying it's the secret weapon these days in many cases of analysis. And one liner on GIS, it is actually the output of remote sensing analyzed into a certain, say, combination of things. So GIS has a hardware, software, and the user. It is just what you can say a totally different branch of analysis. It takes the remote sensing data and it analyzes it for different purposes. It can be environmental management, defense, intelligence, government, resource, exploration, etc. So this can be a satellite imagery, this can be a satellite imagery. We can combine all of them and we can analyze them in a software which is actually the GIS software. But GIS is not in the purview of this discussion, but still I want to introduce it because we should have an idea of how the output of remote sensing is analyzed. Now, directly coming back to business in disaster management, you combine remote sensing. So it is basically dependent on the nature of the remote sensing instrument, what kind of instrument is there, how it is doing the analysis, and how we can actually imply it or apply it in different cases. We can take one or two examples. For example, we have the optical or multispectral sensor. These are the names of the sensors on the satellites. Techniques, we can examine the data which is given by these sensors through manual interpretation, through spectral classification, other different methods, images. These are all technical terms, not required here. But basically, our concern here is the right hand side box. Optical multispectral information can be taken for infrastructure, property damage, earthquake, landslide, flooding, volcanic debris, fire, location of landslides. TEM is used as a supplementary information. If we take thermal, then lake temperatures, sea surface temperature. If we take SAR data, it is very good for change detection, landslides, tectonic movements, flooding, fire, snow analysis. These are some basic examples, but this is how we see that remote sensing can enter into the field of disaster management by its specific nature, by the specific nature of its instruments, because not all instruments are same. There are so many remote sensing satellites, and with the advancement of technology day and day, it is actually providing you so many options that the sensor in itself is advanced, and it is actually giving more information which used to be there earlier. Now, remote sensing can be combined with GIS and GPS. GIS refers to a set of tools and techniques for analyzing and visualizing geographic data. GIS can be used to integrate remote sensing data with other data sources such as population, infrastructure, hazard, to create more accurate and detailed hazard and risk maps. Now, we get information from the remote sensing satellites, but it is one part, that is only interpretation. But how do you identify risk areas? Then after identifying risk areas, you have to identify the transport routes, for example, which are safer or which are less impacted, or which population category in terms of location is more impacted. That analysis is done through GIS. These maps can be used to identify areas that are at the highest risk of damage from disasters and to prioritize mitigation and preparedness for these particular areas. GPS, all of us are aware, they are inbuilt in many systems these days. GPS is giving you a combined information of location, elevation, and other climatic factors, and it is also providing you the routes. So at the time of disaster, but you can in one form use the GPS, but again, it is not providing you information on hazard classification or say vulnerable area classification, but still it is giving you a lot of information which can be combined with GIS and remote sensing data to provide very reliable and efficient maps for operation. Now, the last part of the presentation will deal with remote sensing applications in disaster management. And I've taken it into two categories, natural disasters and human induced disasters. We have a lot of interesting presentations here in terms of pictures, how actually this is taking place and for what all issues they are taking place. Now, if we see natural disasters, many of them are unpredictable. Now, we have seen the nature of disasters. When we see natural disasters and we see remote sensing, why it is necessary, why do we require it? We can do disaster management, we can go in the field, see the affected area, see the affected population, build the damaged structures, and again provide the finances. That can be done, which is actually done for a long period of time. But when we actually see the coverage of the area, we are able to get a holistic information of the surrounding of that area, whether actually that area is affected, because many a times in terms of relief there's a lot of we might have heard of scams which are going on. So whether actually that event has taken place in that intensity for that particular area, is population actually there which is impacted. So all these informations you cannot derive going in the field, and at the time of disaster or prior to disaster, the planning process is very minute. And actually, when the disaster has taken place, it can be such that the area is inaccessible, or it can be such that the area on the whole is not feasible to be accessed every time. So, for that, we need information which is remotely sensed, but which is accurate also. And the best method for that is remote sensing. And in terms of natural disasters, if we observe what is the nature of natural disasters, they are generally unpredictable. The geographical scale is an issue. We cannot access every area, and natural disasters can be interlinked. For example, cyclones, they are followed by floods. It is a very known fact. And right now, you are also experiencing at your side the Mocha cyclone was taking place a couple of days ago, and right now also you have certain disturbance. So cyclone is basically followed by floods, but again, no one can go in that area at that point of time, and cyclone prediction is a very specific concern, and that is only possible these days through the remote sensing information. What is the advancement of the cyclone? What is the path it is taking, or where it will do the landfall? So all these factors, they are extremely significant, because as soon as a warning is received for a cyclone, people are evacuated, and they are not just a handful of people, even one person matters. So the whole population of a particular area is shifted just by knowing that a cyclone is advancing. Then accessibility concerns are there. That is why we need remote sensing. Disaster can be sudden, like in mountainous areas. Some disasters can be tracked, and beforehand warnings can help us in rescue and relief. And one of the best examples in this case is that of the cyclones and that of tsunamis. The Indian Ocean Tsunami Warning System is one of the first ones to be recognized for providing tsunami information, and 2004 unfortunate tsunami has actually led to develop this kind of a system which gives prior information for such an event, which was earlier totally missing. So that was a lesson actually learned from a disastrous event which actually took place all of a sudden. So remote sensing is required because all these aspects are involved. So first example, I'll take that of drought. Drought as a disaster. If you see this image, you can very clearly see there's a ground and it is extremely dry. There is no vegetation, and it is so dry that it has developed cracks. So drought monitoring, again, going in the drought prone area is very difficult. I mean, since already resource crunch is there, it is not advisable to put more pressure. But the identification of this area with regards to its temperature, or with regards to its rainfall factors, or with regards to evaporation, availability of moisture, all these factors can be very conveniently done through remote sensing. So traditionally, drought monitoring has relied upon climatic parameters. These are some well-known indices, but now these indices you can put in the system, you can derive the imagery of that area, do the analysis, and already find out that which area is now under severe stress. For example, pre-monsoon analysis can be done. Post-monsoon analysis is very significant in drought management. And these indices, which were manually done, they can now be done through remote sensing. And one of the best parts is that you can take any area of the world and do the analysis. Either it's a micro scale, it is a macro scale, or it is at the continent level. Obviously, the analysis is basically for a particular nation, or it is at a state level, district level, whichever area we choose, we can do the analysis. So rather than going in the field and investing so much, this examination can be done through remote sensing. In the past 2 decades, satellite-based remote sensing has provided relatively high spatial resolution and high temporal resolution. So spatial means geographical resolution. The area is more accessible and visible, and more data is available for a period of time from hours to days. And I've done this myself in terms of research, that hourly rainfall data is also available. Remotely sensed imagery provides spatial continuous spectral measures across large areas that reflect both atmospheric and land surface characteristics. So by measuring these characteristics, we can very clearly identify the vulnerable areas, we can see population density, and then specific planning can be done for specific areas. Remote sensing data has been increasingly used for large-scale area drought monitoring. For example, several satellite-derived vegetation indices have been developed to monitor drought from local to global scales. Researchers are making progress in developing better drought monitoring tools to assess drought-related vegetation stress, evaluating it with the ground observations. And remote sensing is never saying, okay, don't go to the ground. It is always, I mean, you can say more advantageous to go to the ground and actually see whether the information is matching. And obviously, we are not saying remote sensing is wrong, but uh, taking it with the ground data gives us a very efficient analysis. And even if we are not able to go to the ground, this information automatically is very useful in different forms. In recent years, hybrid drought indices that integrate climate, satellite, and environmental data have been developed. And this is how we can observe it. This is a research from Wiley. It is showing you the different parameters which are analyzed for drought analysis: precipitation, temperature, radiation, water vapor, groundwater, runoff, soil moisture, snow. And if you do it manually, it is very, very difficult to take these parameters and device calculations, because for every station you take the data, do the analysis. But again, identifying the area and getting the data simultaneously is only possible through remote sensing based analysis. These are some other examples of case studies. In Africa, different kinds of data is taken: rainfall anomaly, evapotranspiration anomaly, uh, water indices. NDVI is a very popular parameter of study. Drought indices, SPI, standardized precipitation index, geographically analyzing it for Rajasthan and Gujarat for each of the districts. And this data is taken from remote sensing, and this analysis, what you are seeing, is done in GIS, where we put the specific geographical regions or the maps and do the analysis for that particular area. And we can zoom it into districts, we can zoom this data into villages also, depending on the nature of analysis. This is another example: the use of remote sensing data for drought assessment and monitoring in Southwest Asia. You can take any region and do the analysis. On the right hand side, it is for some regions of China. Monthly analysis of, you can see, rainfall and doing the statistical examination. Okay, then we come on to floods as the second category. Floods can be mapped and monitored with remotely sensed data, which is acquired by satellites and aircrafts. Instruments that record flood events may operate in the visible, thermal, and microwave range. Now, this is a technical aspect of remote sensing, which we have just discussed in that one slide. But different nature of the remote sensing sensors is giving us the output. So the requirement here is to see how we are dealing with disaster management. So this is just to be taken for reference. Now, why remote sensing is useful in flood management? Because the limitations which are posed by adverse weather conditions during flood events, they make the area inaccessible at times. So information obtained from remote sensing instruments like SAR, synthetic aperture radar, active radars, and other instruments is invaluable for monitoring floods. However, if a visible image of flooding can be acquired, having useful information from this is very straightforward. These are some of the examples. This is done by NASA. Monitoring urban floods using remote sensing. Now, urban areas are very compact, they are very dense, and urban flooding is a very significant phenomena. And if we see urban floods, we cannot directly access all the areas in that regard. So, combining the geographical information with the social information, economic information also, we can see which areas are vulnerable, where the direction of water is there, where it can be diverted, or which areas are more vulnerable. These are some examples: flood monitoring using satellite imageries. This is an example of synth flood 2011. With the land use, it is giving the analysis and which are the vulnerable areas. The right hand side photograph is also an example of remote sensing, not from the satellites but from aircraft. So the information can be combined, the information can be taken independently for different kinds of analysis. So apart from providing direct information about flooding, remote sensing data can also be integrated with flood models via model calibration or validation and data assimilation techniques, and it can provide floodplain topography data to augment the amount and type of information available for efficient flood management. So this is actually the preparation stage, or we can say the mitigation stage. In the long term, floods kill more people in the United States than any other weather related event. So, this is an example of a case study. So, each river or coastal area must be monitored at different places along its course. Some flood disasters happen annually, yet others can occur unexpectedly. And this was in news also last year when the Death Valley got flooded. Next example we take is that of the earthquakes, how remote sensing can be effective in dealing with the earthquake study. Remote sensing has been used for earthquake research from 1970s with the first appearance of satellite images. First of all, it was structural, geological, and geomorphological research. So, what did remote sensing do? The main faults and structures which were uh, vulnerable to earthquake occurrence, they were mapped on the basis of satellite images. This method cannot be used for time series analysis, so that there is no possibility to measure short-term processes before and after the earthquake. So that is the limitation, because earthquakes are unpredictable, but still the active areas or some changes can be observed which are taking place and can convert into a geological event. The current situation of remote sensing application for earthquake research indicates a few phenomena related with earthquakes. For example, Earth's deformation, surface temperature, humidity, air humidity, gas, aerosol content. All these parameters can be measured through remote sensing data, and scientists they try to analyze all these parameters and see that whether before earthquake was there any change in any of these, or after the earthquake are they indicating something. Although it's quite in the research domain, but still these information categories are very significant. Then horizontal and vertical deformations of an area, even in centimeters and meters after the shock, they can be measured. So this is an example using remote sensing for active fault analysis. This was a research paper which was analyzing the earthquake in Balakot, what can be the occurrence and what has been historically is analyzed here. So if you see the picture here, it is showing you the area, and this is the satellite imagery information. It is showing the strength of the faults and the output which can be expected. On the right hand side, it is earthquake in Nepal. It is a screenshot of a 3D animation flight over Kathmandu before the earthquake based on 10 centimeter airborne data. So this is an example of airborne platform. Drones are a very good, excellent example of information which is derived on any place, even for events. So for disaster management, the use of drones is becoming very popular these days also. But this is an example of a Nepal earthquake in which a 3D animation flight is shown. This is the area before the earthquake. And then there are many research papers which are published on all of these issues actually. Application of remote sensing and GIS in earthquake triggers landslides, because right now we have just discussed that a disaster can also lead to a disaster. So earthquake triggered landslides are a very significant outcome of that particular disaster which can be studied. And how it is done, I mean, there are specific processes. Then the next category is volcanoes. If you see on the right hand side, the gray central circle is giving the region where the volcanic activity takes place, and all the other pictures are showing you the flow of lava from 2010 to 2012. The thickness of lava is given in the index. Then 2012 to 17, 2017 to 19, 2010 to 19. The scale can be any, it is on the user's choice. And how the area responds to that volcanic activity is being analyzed, and you can very clearly see that the size of the volcano is also changing from where the lava is coming. So catching geomorphological response to volcanic activity on steep slope volcanoes using remote sensing. This is an MDPI publication. So satellite remote sensing can give an improved understanding of volcanic processes and volcanic hazards simply by providing more frequent observations at wide variety of wavelengths. But to be of greatest value to the disaster management community, it is important that the data are made available as soon as it is technically possible. So there can be a different nature of the issue, but still this is one of the examples how for volcanic activity the analysis can be done. This is another example. It is combining the preparedness, response, and again leading to preparedness. So on the left hand side, you can see the three-dimensional digital elevation model of the volcano, followed on the right hand side by the lava flow and modeling by the hazard map, technical training and workshops that if this takes place, this is to be done. On the right hand side, when we take response, detected lava deposits from satellite emergency observation imageries are given. Lahar hazard map is done because lahars are very dangerous waves which follow. And this is in response to the eruption of Mayan volcano in 2009. And finally, on the right hand side, we see preparedness. There's a field work which is taking place to collect ground control points. This is through GPS for the digital elevation model, and this is validated. Any data can be validated on ground also if possible, and then the hazard map is finally revised. So this is the pre-revised map, and this is the one which is revised after seeing the actual ground or the actual field. And it's not necessary that all of them will be different. There can be some variations and there can be a lot of similarities. Next category is forest fires. Forest fires, they are basically these days more caused by human activities. So mapping of burnt areas, assessment of forest fire effect is one of the most successful applications of satellite remote sensing. Satellite remote sensing provides the means to acquire comprehensive and harmonize information on wildfire effects over large areas at a low cost. For this purpose, burnt area mapping is performed with a wide variety of remote sensors and techniques. There are specific satellites which are giving this information, and a wide variety of optical and radar sensors have been used for fire detection and burnt area mapping from local to global scales. And on the right hand side, you can see the map of forest fires for Northeast region. This has been taken from my own research. It is published in a paper in NIDM last year. So I've done this analysis using the Google Earth engine, from where I've taken the forest fire information from 2000, 2004, 2005, 2009, 2010 to 14, and 2015 to 2019. It's a detailed paper, but I've taken a screenshot to visualize how forest fires can be analyzed. Now, this information, if you take satellite information for each of these years through any specific source, then you can combine all of them. And for the whole Northeast region, all the seven sister states, this analysis combined is showing us that all these regions of forest fires, they are experiencing a very dominant activity for all these years. And the strength of the color is showing the strength of forest fires. Then we come on to landslides. Remote sensing for landslide investigation is widely documented in recent literature. In the two most comprehensive reviews, applications are categorized into three main categories. How do we study landslides? Recognizing them, classifying them, then the post-event analysis, landslide monitoring, landslide susceptibility and hazard assessment. And obviously, landslide is also an outcome of earthquakes. It is also an outcome of deforestation. And we have just seen uh, as a disaster, it is an outcome of other disasters also. So the area can be identified through the remote sensing images. Then the different factors can be seen which are associated. Then this vulnerability zoning can be done, and we can actually highlight which areas are under more threat and where the population is residing. So landslide divisions, you can see the source zone, acceleration zone, debris motion zone, sediment zone. So these are all classifications and analysis which are conducted through the remote sensing based information. And otherwise, we cannot do this analysis through any photograph, or we cannot do this analysis manually or just by going to the area. It is extremely impossible. But through this kind of a methodology, the examination becomes very convenient. Then for cyclones, you can see this is showing the strength of the cyclone, area, location, path, and these days cyclones are in a lot of news, and we are coming across these terminologies of cyclone forecasting, early warning, search and rescue operation, damage assessment, relief operation, cyclone prediction and analysis. And we can also do analysis like, say, if a fisherman colony is here, where only fishermen are living. So we can see what is the nature of that colony after or before the cyclone, and the fishermen can be prevented to going into these areas over specific periods of time. And all this is feasible through remote sensing. And you can see the stages of the cyclone in this photograph. Then the tsunami waves, thanks to the recent advances and improvements in satellite sensors, data accessibility, application, services, many space agencies support data sharing policies that facilitate access to remotely sensed data for more efficient use in disaster management. And the Indian Ocean Tsunami Warning System is the best example of this. It is providing information to the countries which are there in the Indian Ocean regarding the tsunami occurrence beforehand. And even 1 minute or 10 minutes before a tsunami are extremely precious. I mean, if you read literature on the 2004 tsunami, this will be very clear in terms of examining. So if this is the area, this is the Andaman Sea, and this is the observation in terms of development of, say, rainfall or other factors which can be observed and detected through the satellite. Or if there's an underwater earthquake, that is also examined, and then it shows the regions where the strength of the tsunami can increase and the regions which are vulnerable. Tsunamis or even dangerous waves, storm surges, high waves, high tides, all of them can be detected. Next category is landslides and remote sensing of this disaster. On the left hand side, you can see the earthquake and landslide in Nepal 2015, during the 2015 earthquake, which was very disastrous for the country. So it hit at a magnitude of 7.8. Epicenter was located near Kathmandu. In addition to Nepal, India, China, and Bangladesh were also affected. And after the event, there were several aftershocks which caused a lot of destruction. But the earthquake also triggered several landslides and avalanches on Mount Everest, and more than 8 million people were affected by the earthquake. Several actors were involved in producing useful information as a response to the disaster. Copernicus EMS was activated by the European Commission's humanitarian aid, and civil 40 products were published at the web page. These are the identified areas, and now also we can do a comparative analysis because 2015 data is available in the satellite imageries because satellites are moving uh, across the earth 24 hours depending on their different nature. So the information from each of these databases can be taken and it can be compared also with the current day analysis to see what kind of developments have taken place after these events. Remotely sensed data gives several important factors used in developing landslide hazard zones. In general, landslide hazard analysis is done using aerial photography and remotely sensed images. High resolution spatial data for factors associated with landslide hazards is important for effective disaster analysis. And we are not going into the details for this. Basically, optical remote sensing, multi-temporal lidar images, these are technical terminologies, but this is how actually for landslides remote sensing can be used. Then the other disastrous event which is discussed a lot in the light of climate change is the GLOF, the glacial lake outburst flood. And on the right hand side, you can see the glacial lake being developing in A, in B, C, D. All of them are showing you suddenly the lake is developing, and this can be very disastrous because after a period of time, if this lake overflows or if it bursts, then the flooding is extremely disastrous. And it is particularly experienced in the Himalayan region that sudden GLOF events are taking place due to climate change. So glacial lake outburst floods represent a major hazard and they can result in significant loss of life. Globally, since 1990, the number and size of glacial lakes have grown rapidly along with the downstream population, while the socio-economic vulnerability has decreased. Now, this is also helpful because disaster management in the long term causes a decline in disasters. It is that efficient. So, if we have information and all these are derived from the remotely sensed images, some of them are photographs. So, it basically is providing you the information where the event is expected. And with the digital elevation or height model or topography model, we can see where this water will ultimately go, and then the loss can be minimized. And since this is not a very populated area, and again our concept is that a disaster is only a disaster when it is impacting us. So if a population is not here, then the threat of this flood is not that dangerous, but wherever the population is located downstream, those areas are to be seen on the basis of a combination of geographical and the social factors, I mean the population density and other factors, where people can get affected. If the water is coming from here, if it is coming from here, or if the flow is at the ground, all of them they have different implications. Next, disaster can be plant diseases, which can be caused basically naturally or due to any specific factor. So on the right hand side, you can see this is an agricultural field, and to remote sensing. Agriculture is also done these days. It is called precision agriculture. And if you read the literature on precision agriculture, you will find that the remote sensing images, they can provide you excellent information regarding the nature of crop. And across the world, this information is used in a number of ways. In India also, it is slowly catching pace. The nature of healthy vegetation is a direct indicator of the quality of that vegetation, and in this case the crop. So mapping with remote sensing images, you can find the damaged crops or the damaged areas, and they can be immediately monitored in terms of pest management, which is not very feasible being on the ground directly, it might not be feasible for large areas. So the healthy vegetation can be distinguished from the unhealthy vegetation through the nature which they are showing in the remote sensing images. So plant diseases and pests endanger agriculture and forestry significantly around the world. The implementation of non-contact, highly efficient and affordable methods for detecting and monitoring plant diseases and pests over vast areas could greatly facilitate plant protection. In this respect, different forms of remote sensing methods have been introduced. See, each of them in itself is a specific study. It is that vast. We can also take example of human-induced disasters, accidents, emergencies. On the right-hand side, you can see the photograph of search for Malaysia Airlines flight 370, which disappeared on March 11, 2014, and the CMA requested the charter supporting Malaysian Airlines. The aircraft disappeared from radar on March 7th with 239 people. Till now, there is no information, but satellite imageries are taken of the area to do some kind of fact finding. So, satellite images have revealed suspected debris or a spill of oil of the missing aircraft in a number of locations at different places. It has indicated that there is an oil spill, which can be an outcome of the crash of that plane. But despite efforts to search an area of the southern Indian Ocean, no trace of the plane has been found. So we are not saying that remote sensing is the only answer to everything, but it can provide us so many opportunities, so many vistas which were earlier not there, and there were so many limitations in the study of different parameters which are now being made more advantageous through remote sensing. So, in case of human induced disasters, say terrorism, which is the most serious problem in many parts of the world, activities like landmine blast, railway track damage, disruption of power supply units, destruction of transport, all of these can be tracked through remote sensing. Effective response to natural and human induced disasters requires rapid analysis of images and other sensor data before the event and after the event. Such information will enable emergency response services to clear blocked transportation routes rapidly, and it can also help in rerouting the transport facility. Likewise, recovery efforts depend on the acquisition and analysis of timely imagery and other remotely sensed data, which can indicate the presence of arms, explosives, and ammunitions. Then emergency diseases like pandemics. The role of remote sensing during a pandemic is very significant. And if you read literature on COVID-19 and remote sensing, there are so many parameters. I have also published a research dealing with climate change, dealing with forest fires during COVID, dealing with other climatic parameters, which can cause change in the other parameters in the absence of human activities. So remote sensing is providing us a lot of platforms to examine these kinds of data. Role of remote sensing during a pandemic, it can be multifaceted. We can study the environment, monitor the influence of human activities on pollution, evidence for improved environmental policy. Then in epidemiology, supplying meteorological and air quality data used in epidemiological studies to find disease determinants. Economy and society to see the geographical distribution and time of the change in industry and other sectors. See the food shortage, job losses, supply disruptions, and combining it with the data on the ground conditions, the examination can be very effective. Then extreme weather phenomena, another natural category of events, storms, tornadoes, hail, extreme heat and rainfall. In all parts of the world, these researches and these weather related informations are taking place. So on the left hand side, you can see the cyclonic information. These bands are showing the thunderstorms. On the right hand side, we can see hailstorm detection by satellite microwave radiometers, where the intensity of the hail can be maximum is shown in red color. And these days, I mean, we take it in a very passing off manner. Okay, today rainfall will take place, today hailstorm will take place, today we'll have a dust storm. Like in Delhi, for the last 2 3 days, we are having a dust storm. All these have been predicted earlier. But if we see the implication of this, it is actually too much on our lives. But where is the source of this information? Where it is coming from? It is coming from the satellite information. So if we have prior information, it is definitely helping us in our day-to-day lives. And hailstorm prediction is very common these days, but it is very effective. Extreme heat information, which is provided for the city, which we actually come across every day in the newspaper in terms of temperature change, is very helpful. And it's only at certain times that we find that there is deviation. But on the whole, this information is extremely accurate. And all this is possible through the advances which have taken place and the methods which are implied. Then we can take ocean monitoring, ocean color, sea surface temperature, chlorophyll, nutrients, ocean atmospheric phenomena, storms. All of them can be predicted in terms of their analytical analysis, and they can also be applied for other parameters. This is an example of a recent study being conducted by NASA. The first one is giving you development and implementation of remote sensing techniques for oil spill monitoring and storm damage assessment in an operational context. So you can see oil spill and storms. There is actually, if we take it in terms of terminology, no relation. I mean, anyone will say, okay, oil spill and storm. So what we'll do in this analysis? But all kinds of analysis which we can think, which we can even anticipate, or which are latest in nature, they are being done these days in disaster management. And this is tagged under disasters category of NASA's analysis. And you can see the satellite imagery, which is very clear in nature. You can see the oil spill. And if we zoom it out, we'll see actually what is the extent of that area which is impacted by that oil spill. And if a storm takes place, then where is this oil going? We can't stay in the water and do this examination. Maybe these instruments, they can monitor to some extent, but they're not that effective. But through remote sensing information, these areas can be very clearly seen that, okay, if the oil spill was there in that area and a storm has taken place, where is the oil spill moving? And again, the impact on vegetation, impact on the animal life, impact on people, if I mean it is next to the coast or whatever the situation is, that can be examined. Then the second study is saying using NASA Earth observations to assess coastal flood risk with measures of land cover change, flood extent, and vulnerability for adaptation and mitigation planning on Hawaii Island. So you can see so many parameters covered in one go. We see the coastal area, we see the flood risk, we see the land cover change, we see the flood extent, where the flood is moving, and which area is vulnerable. Now, vulnerability, the remote sensing image is not saying, okay, this area is vulnerable. We have to find out which area, why it is vulnerable, because, say, for example, a flood is taking place, so the houses are in the way of the flood. There are so many people who are living. If the flood is just passing by that area, it is not a disaster, it is not impacting. So vulnerability is actually calculated through the different methods, or we can put the combination of factors in the GIS and find which area or how much area is more impacted on the basis of the parameter we study. So in one go, there are so many different factors which can be combined. The land cover change, flood extent, and the vulnerability with adaptation, etc. And then finally, we come on to, after so many examples, definitely no method is foolproof. So there are limitations in the remote sensing method in terms of disaster management. So the limitations can include inability to collect data. For example, during violent weather conditions, if the weather is violent, say for example, we have clouds, we have dust storms, we have storms, thunderstorms, or we have a very thick cloud cover, then the satellite sensor cannot detect the information. And if you remember the initial slides, the remote sensing method involves atmosphere as a basic factor, because everything which is coming from an object or which is coming from the space to the object has to pass through the atmosphere. And atmosphere, we have just discussed, has a lot of components and it has a lot of processes. It is very dynamic depending on the location of that particular place on the earth. For example, at the high altitudes, the atmosphere is not very thick because of the nature of the atmosphere. The lowest layer of the atmosphere, which is the troposphere, is having the maximum height at the equator. Then the different layers, when we move up, their heights are different. And when we move further up in the atmosphere, the thickness of the atmosphere is minimum because of the physical properties of the atmosphere. Again, the sun rays entering from all these layers to the objects, it is given back in the form of radiation by these objects back to the atmosphere. Again, when these rays are given back, there is moisture, there is dust, there is nature of dust particles, there is the nature of what we can say the specific location, effect of buildings, impact of vegetation, impact of industries, impact of transport. So the nature of the atmosphere is altered with respect to temperature, with respect to moisture and other conditions. So this information, when it is going to the sensor, is facing these obstructions. And all these obstructions are also recorded by the satellites. And then we do changes by correcting, that's the technical aspect. And finally, we derive the data. So during violent weather conditions, it is difficult to collect data. Medium to low spatial resolution. Resolution, in simple words, means the clarity of the information. So spatial resolution is one property of the satellite imagery. Spatial means a geographical scale. At what scale this information is taken. So if the scale of information is different, then the area is not clear or it is very clear. So depending on the remote sensing sensor, the data is derived. The limitations include inability to collect data during violent weather conditions, medium to low spatial resolution, and assessing areas and pixels on a damage, no damage basis. Recent advances in active remote sensing data collection can resolve some of these limitations which were there earlier. So satellites in space, they hold the key to preventing disasters on Earth. So right now we are talking of disaster management. So if we go on to the practical aspect, remote sensing is offering us uncountable in numerous avenues to examine, to research, to analyze, and to find out which disaster we are focusing on, which area we are focusing on, what is the extent of that area, what are the characteristics, and even population analysis also is done these days through remote sensing examinations. And in combination to remote sensing and GIS technologies, they give valuable data. They are also providing information and they're also providing analysis, which can help decision makers better understand the cause and impact of disasters, prioritize the response, reduce the risk and consequences of future disasters. And combining both of them, both the fields are advancing and their potential for even greater impact in disaster management is expanding very constantly. And there's a lot of literature on remote sensing. There's a lot of literature on GIS, purely on remote sensing and GIS, how any specific event is studied and how any specific event can be managed actually using both these technologies. One of the most important uses for remote sensing is mapping. The technology is used in many kinds of monitoring. As the earth, climate, and the impact of humans on the environment are constantly changing, so do our maps also need to change. And historical data is not at all possible to derive unless we have this remote sensing information, which is extremely valuable even for some cities. Say Delhi, we have information for the land cover and land use since 1960s, which is otherwise not feasible. Through remote sensing, we have this data. So remote sensing and GIS are critical components of modern disaster management. Currently, the trend is of hyperspectral remote sensing, which is a combination of uncountable bands to give more reliable information of remotely sensed data. Without these satellites and remote sensing techniques, today's mapping technologies would be incapable of delivering the vital contribution to managing our planet better to the benefit of all. And a few lines on hyperspectral remote sensing. Initially, we had remote sensing sensors which were limited in nature. These sensors they used to provide us information which was of a what you can say a rough nature. Slowly and gradually, there was a development in remote sensing, and we had the upcoming of GIS in combination, and this was further taken up with the advancement of sensors, which were moving in the direction of providing different kinds of information for the areas with specific requirements, like we have seen for pest management, we have seen for floods, the landslides, cyclones, etc. And with these sensors, there was more clarity. And then currently, we have a lot of other satellites which are providing us information at a very, what you can say, clear scale. But due to a defense perspective, due to security reasons, this information is not available in the public domain. So, whatever information we have for the current day satellite data, although it is advanced, but still everything is not available in the public domain. This is very significant to be examined. We cannot call it as 100% limitation of remote sensing, but due to security reasons, this has to be done. And with this, the advancement in remote sensing in the hyperspectral domain has also taken place. So hyper and spectral, these are two terms. Hyper means obviously the momentum and the intensity of the particular aspect is extremely varied, and it is extremely high as compared to the traditional methods. So in hyperspectral remote sensing, there is a combination of a number of bands. They can be, say, uh, hundreds of them. And when these hyperspectral images they are compared, then the information which is derived through traditional remote sensing is seen to be what you can say somewhat lacking, but the hyperspectral data is giving us even the minute informations which are available for a particular area. But again, hyperspectral remote sensing is gaining popularity in remote sensing literature or in remote sensing data analysis, but specific softwares for analyzing them are developing. And in the developed world, we have more analysis on hyperspectral information, but currently in the developing nations, we don't find too much of implication or too much of analysis involving hyperspectral data, but still it is providing us a lot of information which is actually uncovered in the traditional remote sensing methods initially. And when you combine GIS and remote sensing, you will find that the output is more enhanced. In GIS, we can put our own criteria and do the analysis, and we can do the outcome, we can take the interpretations, and we can suggest that this is the vulnerable area, this is the less vulnerable area, this is the characteristic of population, and this is the final output. For example, we can take income parameters, we can take population density, we can take the size of houses, we can take the number of people living in a house, we can take the education level or gender issues, or I mean gender analysis, and then we can devise our own formula that okay, if all these factors are combined, or if this factor is more, then this is the probability of that hazard. If this factor is less, this is the probability of that hazard, and so on. For example, if a flood has to take place in a particular area, what is the size of the field, where are people living, what is the nature of the crop which can be examined, like we have seen in pest management, or what is the, say, education level of people. We can combine all these parameters in a formula, and then we can do the examination as to which area is more vulnerable. Or if we totally leave the social factors, we only take the natural or geographical factors, then we can find okay, this is the elevation of this area, this is the change in elevation, this is the height of the area, or The river is flowing from this area to that area. This is the watershed, and this is the nature of the flow, and the water will come from here to here. And the nature of the water is that it can cause harm in this volume, and this is the volume of that particular flow. So we can have a combination of analysis, and then we can derive vulnerable areas. Or if a disaster has taken place, then we can actually find out where it has taken place. For example, in a landslide region, where the blockages are there, where the transport accessibility is there, where can the transport move in the absence of accessibility, which areas are more vulnerable if still rainfall is taking place, or which areas are actually under threat through that, say, future landslide, and so on. And the Kedarnath tragedy has been well documented in many of the remote sensing and GIS literatures. You can have a look at it to observe as to how the examination is done. And many what you can say, pre-disaster studies for mitigation, they are also taking place to observe how we can contain the disaster, or where we have to manage the disaster, which areas are showing more vulnerability. And if we put the information of social vulnerability with the GIS software, we can do our own calculations and derive what you can say, a mathematical formula to apply to that area and prevent what we can say, a kind of tragedy situation. Then for droughts also we can have similar things. For drought management, it is very effective. Rainfall trends, rainfall parameters, changing temperatures, impact of climate change, and basically a combination of evaporation, temperature, and other parameters. It can be very helpful. So without these satellites and remote sensing techniques, today's mapping technologies would be incapable of delivering the vital contribution to managing our planet better to the benefit of all. So we cannot ignore the role, neither can we ignore the importance which this data methodology has gained in the current context of disaster management. These are my references, and thank you. If there are any questions, I'll be happy to take.